Well, hey there, kiddos. Today we're going to talk about literal equations, which are just equations that have multiple variables in them. There's usually, you see them in the form of formulas, like when you're in science class and you're needing to solve a formula, that's a literal equation. And so we're going to use these literal equations today. We're going to learn how to solve with them. It's no big deal. We're just going to be solving for a variable like we have been. So we're going to start simple. We have a research station run by the National Oceanic and Atmospheric Administration, also known as NOAA, observes waves to determine the strength of a storm. To do this, they measure the vertical distance from high point to low point and the horizontal distance between adjacent wave crests. The formula below describes the relation between speed, frequency, and wave length. So here's what you know. V stands for velocity. It's going to be the speed of the wave. This F stands for the frequency of the wave. This should be a multiplication sign. For some reason it turned into a square. And this funny little symbol is called a lambda, but it stands for the wavelength. So we're going to use this formula to calculate the velocity, the speed of a water wave, if the frequency is 0.5 cycles per second and the wavelength is 6 meters. And so we're just going to use that formula. The velocity is equal to, the frequency is 0.5 cycles per second, the wavelength is 6 meters. And so when I multiply that together, I get that the velocity is 3.0 meters per second. So there is the velocity of the wave. That's how fast it is moving. And so that's how we use the equation. That's how we use the formula. So now suppose that we wanted to solve for another variable in this equation. For example, I want to try solving for that lambda. So here is the equation. V equals V times lambda, which is that funny looking little upside down Y. So the first question says, what variable are you being asked for? Well, we're being asked for lambda, so we're going to circle it. That's the one we want. What operations happen to the variable? Well, what's going on here is I have frequency times lambda, so it's multiplication. So I'm going to undo it. To undo it, I need to divide by f on both sides. And so in order to get lambda by itself, the velocity divided by the frequency gives me lambda, which is the wavelength. So it's simplified, we're done. That is how you solve a literal equation. The difference between today and what we've been doing is that your solution is going to be an equation. All I'm really doing is rewriting the formula so that I can use it in a different form. So now we have another question. A sound wave is traveling with a speed of 343 meters per second. So there's your velocity. Calculate its wavelength, which is that funny lambda sign, if the frequency of the wave, so there's your frequency, is 0.686 cycles per second. So now I know the velocity and the frequency. I can plug them into my rewritten equation. The velocity is 343. The frequency is 0.686. I need to know what that gives me. And so when I divide that, I get that 500 meters is the wavelength of my wave. So that's the answer to that one. And I just rewrote my equation so that I could just plug in and solve straight from there. So let's do a few more. So we have the area of a triangle can be found by using the formula. So the formula for area of a triangle is A equals base times height divided by 2. So we want to solve the formula for the base of the triangle. So the variable that I want, I'm going to rewrite it down here. Base times height divided by 2. The variable that I want is this b, because that's what I want to be by itself. So I've got to undo everything else. The operations that I have happening with the base over here is being multiplied by the height and divided by 2. So the first thing I need to do is get rid of this divide by 2 because it is in the denominator. It will make things easier. So I'll multiply by 2. So now I have 2a is equal to base times height, and I still want the base by itself. So I have to undo this multiplication by doing division by h. And so my final answer is 2a divided by h gives me the base. Pardon me. So part C, you have a triangle that has an area of 96 centimeters. So there's your A, centimeter squared, and a height, your h, of 8 centimeters. We want to find the base of the triangle. So we're going to use our rewritten formula. So I have 2 times the area, which is 96, divided by the height, which is 8, will give me the base. And so I just grab my calculator. And I get that 24 centimeters is the base of my triangle. So I rewrote my equation so that the base was what was by itself, and then I used that rewritten equation to find the base. So number 3, you've got a soap company who wants to use a cylindrical container to hold their new liquid soap. The formula for the volume of the container is V equals pi r squared h. So here's your formula. The first thing we want to do is solve for h. So I'm going to rewrite the formula. V equals pi r squared h. I want h by itself, and the operations that are happening with the h is it's multiplied by r squared and by pi. So to undo it, I'm going to divide, and I can divide by both of those things at the same time. So I can cancel them both out, so I can do the same thing on this side. So h is now by itself, so the volume divided by pi r squared will give me the height of that cylinder. So the second question says, what's the height of a container if the volume is 56.52 cubic inches and the radius is 1.5 inches? Then it says round to the nearest tenth. So we take our formula. The volume is 56.52 divided by pi times the radius squared. So that's 1.5 squared. Now I'm going to leave this pi symbol in there. I'm not actually going to take it and make it 3.14 and multiply. The first thing I'm going to do is 1.5 squared. So I can simplify this a little bit. So I have 56.52 divided by, and 1.5 squared is 2.25 pi. I can reverse that order because it's multiplication. Pi times 2.25 is the same as 2.25 times pi. I just like the pi to come second. And so then I'm going to divide 56.52 divided by 2.25. And so I get I take that back. We're not going to divide because we still have that silly pi symbol in there. I guess we could rewrite it as 25.12 divided by pi. You could leave it like that, or I lied and said we weren't going to really multiply it. We could. We can do 2.25 times 3.14 for the denominator, and we could rewrite it, which I'm going to do because in this problem it makes more sense. We're really trying to find the height of the thing. So the denominator of this becomes 7.065. So I really did make that 3.14 multiply. And so that's my 56.52. Now I'll divide by the 7.065. And so I get that the height of my cylinder is going to be 8 inches. That makes more sense than leaving the pi in the answer because you're actually dealing with the dimension. So I would rather you go ahead and multiply it out. All right, one last question. This is the last one on your notes. It's number 9. It says the kinetic energy, Ke, of an object is the energy it possesses because of its motion. When we look at the formula in a minute, this Ke is one variable. It's not two separate ones because it stands for kinetic energy, which is the thing. So the formula for kinetic energy is Ke equals 1/2 mv squared, where m is the mass and v is the velocity of the object. We want to solve this equation for the mass of any object. So we have the kinetic energy is equal to 1/2 mass times velocity squared. And I want to find out the mass. And so I circle it. The things that are operations that are happening, it's multiplied by 1/2 and it's multiplied by v squared. Well, the first thing we should do is we should clear out that fraction. So we're going to multiply everything by 2 so that we can get rid of the fraction. So I have 2 times the kinetic energy is equal to, now the 1 doesn't matter, you can put it or not. So I have mv squared. My 2's canceled. Now I've got to get rid of the v squared because m is still not by itself. So I'm going to divide by v squared. And so I get that 2 times the kinetic energy divided by the velocity squared is equal to the mass. This would be the equation that you would use if you wanted to find the mass of the object. You don't always have to solve for the variable in order to solve the equation, but sometimes it's very helpful. If you just want to know how would I find it, that's what you would do. And so literal equations are just, here's the formula, let's rewrite it so that it's in a different form so that I can find a different one of the variables, because literal equations are always going to have multiple variables happening. So that is literal equations. We'll practice that when you guys come to class tomorrow, and I will see you then.